Okay, in guide sheet number 3, we dealt with determining when or determining if total mechanical energy was conserved or not. We're going to look a little more in detail here about how work is done to either change, to either increase or decrease the energy of an object. Okay, so whenever something is done, mechanical energy, the energy of moving things or things that are being applied forces, etc., typically what will happen is some of that energy will turn into other types of energy, like thermal, the energy of heat, making the molecules move faster, light energy, it's a form of electromagnetic energy, electricity, also a form of electromagnetic energy. So typically we're going to transfer some energy into something else. So if you rub your hands together, that mechanical energy is going to turn into heat, your hands are going to get hot, or at least warmer than they were before. That's an increase in thermal energy. That thermal energy has to come from somewhere. It comes from a loss of mechanical energy. Now, forces can be internal or external. If we have here our list of wantif forces, they can be either internal, meaning from within the object, or external, coming from the outside. Now, if we're listing which ones are internal, the force of gravity is based on mass, that's a property of matter, and the force of a spring is within the stretchiness, the nature of the spring itself, so that's internal. All the other forces come from outside the object, and therefore we classify them again as external forces. So our normal force, our friction force, our air resistance force, applied forces, and tension forces would all be external forces. Now, if the work being done is done by external forces, it will change the total mechanical energy of the system. If the work being done is only being done by internal forces, then it will not change the total mechanical energy of the system. The total mechanical energy would then be conserved. Okay, so always true, not true, or might be true for these statements. If gravity does work upon an object, then its total mechanical energy is conserved. That might be true. If there are no other forces acting upon it, then the only force acting upon it was internal, then it would be conserved. If only another force like a spring force, which is internal, would act upon it, then it would also be conserved. But if any of the external forces act upon it, it will not be conserved. If gravity is the only force, then that's going to be always true. We will be conserved. It's an internal force. If only internal forces act on the object, the energy, total mechanical energy, will be conserved. If a normal force acts upon an object, then its TME will change. Now, this again might be true. If the normal force is 90 degrees to the motion, then the cosine of 90 is 0 and no actual work would be done. So there is an external force present, but it's not doing work. So an external force has to do work in order to change the total mechanical energy. If sliding friction does work upon an object, then its TME will decrease. Again, that's a might be true. Sliding friction could actually make you speed up. If you think of say when you're walking, the force of friction is actually what drives you forward. So it won't necessarily reduce your total mechanical energy, but it definitely will cause change from the sliding friction if it's not at a 90-degree angle. So it's a might be true. E, if only external forces are doing work upon an object, then its TME will be conserved. Now again, that is a might be true. If you push forward with a force that's equal to the force of friction resisting you, the total mechanical energy is going to be increased by the applied force and decreased by the friction, so the total will actually be conserved. So it might stay conserved with external forces acting, but it certainly will not always be true. F, if both internal and external forces are doing net work upon an object, then more information is needed to tell if its TME will be conserved. And that is always true. We need to know what external forces are working. Are they canceling each other out? Are they doing the same amount of work but in opposite? Some adding energy, some subtracting energy. We need to know more to tell if we're conserved or not. And G, if a quantity such as total mechanical energy is conserved, then that means it does not change over the course of the motion. Total mechanical energy is conserved. That means the TME is going to stay the same. Now, it's not that the individual amounts of mechanical energy don't change, but the total is not going to change. Okay, so kinetic plus potential, kinetic plus gravitational potential, kinetic plus spring forces, and therefore spring potential energy, that sum has to stay the same. Okay, in each case down below, we're going to see if the energy is conserved, and therefore if we think external forces are doing work. In number 3, the first one, we have 100 total here and 100 total here. When we sum them up, it stays the same. So yes, we have total conserved. Are there any external forces doing work in this case? Since the only external force I could think of would be air resistance, and it wouldn't be counterbalanced by a driving force, I would say no. We're assuming here that there's no air resistance or frictional type forces. And the next one, we're 5,000 total and 4,500 total. So no, we are not conserved. We have less than we started with. And in this case, yes, there's going to be external forces, most likely some kind of air resistance or friction, which acts against the motion since our total energy went down. 8 is the total here, 6 plus 2 is 8 is the total there, so it is conserved. And therefore we're assuming no external forces are doing work in that. Gravity is going to pull it downward, but that's an internal force. It's maintaining the same amount of energy. Now if it's 8 joules here, we would be justified in saying that it's going to be 8 joules here and 8 joules here and 8 joules here. We'll assume if it's conserved throughout the entire motion, it's going to stay the same at each point of the motion. The only way it can do that, in this case, if there's no external force. Again, there's no driving force to counterbalance the friction or air resistance, so we must assume that there is no friction or air resistance. Okay, so we're going to stop it there, and we'll look at a couple more cases in the next episode of how total mechanical energy may or may not be conserved.